Hey guys, it's Big Ben once again. Welcome to the SOAIR Cybersecurity Guide, and this is the week 5, section 10. We're discussing securing web application. We'll be discussing the secure coding practices and input validations. We'll be understanding web application firewalls, which are the WAFs. We'll be having our assignment, which is to add in a more vulnerable web application. Now we have the secure web application. Web application security is essential to protect sensitive data, prevent unauthorized access, ensure the integrity of online services. This guide outlines the best practices for securing a web application, covering authentication, data handling, server security, API security, monitoring, and more. Securing a web application involves implementing various measures to protect it from cyber threats, data breaches, and unauthorized access. Here are the key aspects to consider. Number 1, we have the authentication and authorization, whereby using strong authentication, which means to implement multi-factor authentication, which is the MFA. Next, we have the securing passwords. We ensure strong password policies and store passwords using bcrypt or Agon 2. The next, we have the OAuth or the OpenID Connect, which use secure authentication mechanism instead of rolling your own. We have the role-based access control, which is the RBAC, which ensure users have only the permissions they need. Number 2, we have the secure data handling. Under that, we have the encryption of sensitive data. Use AES-256 to store data and TLS 1.2 plus for data in transit. Next, you sanitize input data, which means you prevent SQL injection and XSS attacks by validating and sensitizing users' input. Next, you use a secured cookies. Enable HTTP only, secure, and same-site flags to protect session cookies. Number 3, we use secure coding practices by avoiding hard coding secrets, by storing API keys and credentials in environment variables or vaults. Next, you use prepared statements. This prevents SQL injection by causing parameterized queries. Next, we have the escape output properly, which you use libraries to escape user-generated content, e.g. escaping HTML to prevent XSS attack. Next, you implement content security policy, which is the CSP, which prevents injection attacks by specifying allowed content sources. Number 4, we have the protection against common web vulnerabilities. Number 1, we have the cross-site scripting, which is XSS, which uses CSP and output encoding. What is CSP? Content security policy. By using CSP and output encoding. Next, we have the SQL injection. You use the ORM or prepared statements. Number 3, we have the cross-site request for that is CSRF. How do we prevent this? By implementing CSRF tokens. Number 4, we have the security headers. How do we prevent this? By enabling HTTP headers like the X-frame option, X-XSS protection, and strict transport security, that is the HSTS. Number 5, we have the secure server configuration. We keep software updated by regularly updating web server frameworks and library. Next, you disable unused services. This reduces the attack surface by turning off unnecessary features. Then, you use a web application firewall. This protects against common attacks like the DDoS attack and the SQL injection. What is the DDoS attack? Distributed denial of service attack. Next, you limit rate of request by implementing rate limiting to prevent abuse and brute force attack. Next, we have the secure APIs. Use API gateways, which means you manage access and security policies centrally. Next, you implement rate limiting. This prevents API abuses and DOS attack, that's denial of service attack. Then you use OAuth for API authentication. Secure API endpoints with token-based authentication. Next, you validate input data. This prevents malicious API requests. Number 7, login and monitoring. Enabling login, this captures security relevant events, e.g. your failed login or suspicious activity. Next, you use SIEM system. Integrate with a security, information and event management tools for real-time analysis. Next, you monitor anomalies. Set up alerts for unusual activities. Next, you have this regular security testing. Conduct penetration testing. Test for vulnerabilities before attackers get there or before attackers do. Next, you perform security code review by identifying potential security flaws in source code. Then, you run automated security scanner by using tools like OWASP, ZAP, Bob Suite, and the Nexus. Number 9, we have the secure deployment and hosting. Use HTTPS everywhere. What is HTTPS? Hypertext Transfer Protocol Secure. This redirects all HTTP traffic towards HTTPS. Implement zero trust security. Verify every request inside and outside the network. Again, container security. If using Docker/Kubernetes, scan images for vulnerabilities. Next, you restrict public access. Minimize exposed endpoints and use private networking. Number 10, we have the backup and incident response. Regular backups by ensuring encrypted regular backups of critical data. Next, you have the disaster recovery plan. Have a plan in place for responding to breaches. Next, you have the security awareness training. This educates developers and employees about security best practices. Secure coding practices and input validation for web application. Number 1, prevention for SQL injection. Use prepared statements and parameterized queries. Never concatenate user input in SQL queries. Use ORM, which is the Object Relational Mapping Libraries. ORM frameworks like SQLized Node.js, SQL Alchemy, which is Python, or Hibernate, which is Java. This prevents for SQL injection risk. Example of safe query using parameterized queries. That is the Python with SQL Alchemy. That is the line of code below. Next, how do you prevent the cross-site scripting XSS? By using escape output properly. Use frameworks that automatically escape output, e.g. React. Next, you have the content security policy, that's the CSP. Define allowed sources for scripts and style. Again, we have the sanitized user input. Use libraries like the DOM Purify for cleaning HTML input. Example of escaping HTML in JavaScript is the lines of code below. Number 3, secure file upload handling. This restricts file types and validates MIME types. This stores uploaded files outside the web root. This renames files to prevent direct access. This scans and uploads files for malware. Number 4, we have the prevent cross-site request forgery. That is the CSRF. Use CSRF tokens in every form submission. Implement same-site cookie setting, which is the same site equals to strict or same site equals to lax. Then require re-authentication for critical actions, more like the changing of passwords. Then we have the input validation best practices. Proper input validation ensures that user supply data is safe before being processed. One general input validation rules. Use whitelisting instead of blacklisting. This defines allowed characters for input instead of filtering disallowed ones. Next, you validate on both client and server. Client-side validation improves users' experience, but server-side validation is essential for security. Under the input validation best practices again, is to reject unexpected input types. Validate input format, e.g. dates, emails, and number. Then, validation techniques. Number 1, allow only expected data, which is you use strong type validation for all inputs. You reject unexpected character, e.g. your non-numeric input in a numeric field. Next, you use the security header for protection. Next, you use the security headers which help mitigate common web vulnerabilities. We have few types of headers here and their purpose. We have the strict-transport-security, which means max 8 equals to 31536,000, includes subdomain. This enforces HTTPS, that's the Hypertext Transfer Protocol Secure. Another header is the X-frame-option which means deny. This prevents clickjacking. Then we have the X-XSX-protection :1 semicolon mode equals to block. This blocks XSS attack, which is the cross-site scripting attack. Next, we have the X-content-type-options :non-sleeves. This prevents MIME or type sniffing. Next, we have the content-security-policies :default-SRC inverted bracket self. This restricts resources to same origins. What is a web application firewall, which is the WAF? A WAF is a security system that monitors, firstly, filters and blocks HTTP/HTTPS traffic to and from a web application. It acts as a shield between the web application and the internet, protecting against threats such as the SQL injection, XSS cross-site scripting, cross-site request forgery, that's the CSRF, and other web-based attack. Unlike traditional firewalls, which monitor network traffic at the packet level, WAFs focuses on the application layer, which is the 7th layer of the OSI model, to detect and mitigate malicious web traffic targeting web applications. How does a WAF work? A WAF operates by analyzing HTTP or HTTPS requests and applying a set of predefined or custom security rules. It can be deployed in different modes. Number 1, we have the request inspection and filtering, which examines incoming and outgoing web traffic, which blocks or allows requests based on configured security rules, which protects against SQL injection, cross-site scripting, cross-site request forgery, file inclusion, and remote code execution, which is the RCE. Number 2 of how the WAF works is rule-based protection. It has the rule-based protection. This uses security policies, blacklist and whitelist to allow or deny traffic. This employs signature to detect known attack pattern. Next, it includes behavioral analysis to detect anomalies. Number 3, how does it work? For learning and adaptive security, some modern WAFs use machine language, ML, or AI, artificial intelligence, to detect zero-day vulnerabilities, adapt to new threats, and update protection policies automatically. What are the types of WAF deployments that we have? We have number 1, network-based WAF, which installed on premise as hardware appliance or network gateway. It has low latency and requires high initial investment and maintenance. Number 2, we have the host-based WAF, web application firewall. This is installed as a software module on the web server, provides deep application visibility and consumes server resources. This is common in self-hosted web applications. Number 3, we have the cloud-based WAF, which is managed by third-party providers, e.g. your AWS WAF, Cloudflare, Imperva, or Akamai. Next, it has easy deployment with minimal maintenance. Then, it protects against DDoS attack, distributed denial of service attack, and integrates with CDN for performance enhancement. What are the key features of the WAF? Number 1, protection against OWASP top 10 threats. SQL injection, which blocks attempts to execute unauthorized SQL queries. Protection against the cross-site scripting, which prevents malicious script execution. Protection against the cross-site request forgery, which blocks unauthorized users' action. It protects against remote file inclusion, RFI, which prevents unauthorized file execution. It protects against security misconfiguration, which detects an alert on weak security settings. Number 2 key feature of the WAF, it has the rate limiting and DDoS protection. Limit the numbers of requests from a single IP. Then it mitigates bot-driven attacks and denial of services attack. Number 3, under the key features of the WAF, it has the IP with whitelisting and blacklisting. It allows or denies requests based on IP addresses, geolocation, and ASN. It protects against brute force attack and credential stuffing. Another key feature is the API security. It filters API traffic and protects against REST and GeoQL API abuse. It blocks the API-related attacks like API scraping, authentication bypass, and rate limit evasion. Advantage of using a WF: real-time threat detection and mitigation is number one. Number two, compliance with security regulation. We have the security regulation, which is the PCI/DSL. We have the GDPR, which is the General Data Protection regulation. We have the HIPAA. These are all compliance regulatory bodies. It's number three, improved application availability and uptime. Next, it protects against automated threats, which are the bots, scrapers, or spam. Next, it enhances visibility with traffic monitoring and logging. What are the limitations or disadvantages of web application firewalls? It cannot protect against internal threats or compromised credentials. Misconfigured WAF rules can lead to false positives or negatives. Then again, we have the advanced persistent threats, that is the APTs, may bypass traditional WAFs. Next, it requires ongoing tuning and monitoring for optimal effectiveness. Popular web application firewall solution. Number one, we have the cloud-based WAF. Cloud WAF integrated with CDS protect against bot attack. AWS WAF works with AWS services, which is the API gateway or load balancer. Akamai corner side defender, which protects large-scale enterprise application. Empower Cloud WAF, which is AI-driven security and bot mitigation. We have the Google Cloud Armor, which works with Google Cloud application, and we have the on-premise WAFs. Number two, which is the on-premise WAFs, is the Mode Security, which is the open source WAF, which works with Apache, Nginx, and IIS. We have the F5 Advanced WAF, which is a comprehensive application layer security. We have the Barracuda WAF, which offers both physical and virtual appliance solution. We have the Fortinet FortiWeb, which is AI-driven threat detection and API security. We have the Citrix WAF, which is part of the Citrix ADC platform for enterprise security. Best practices for configuring a WF. Number one, enable logging and monitoring. This keeps track of block requests and security events. Use a positive security model. This allows only known good traffic instead of blocking bad traffic. Next, we have to regularly update WAF rules. This ensures protection against evolving threats. Again, we have the customized security rules, which adapts WAF policies to your application's need. Next, we have the integrate with SIEM security. This sends logs to security information and event management for analysis. Next, we have the perform regular security testing. Use penetration testing and vulnerability scans to check WAF effectiveness. In conclusion, a web application firewall is an essential security layer for protecting web applications from cyber threats. Whether deployed or a cloud-based service, on-premise appliance or software module, WPF, which is the web application firewalls, help to mitigate attacks like the SQL injection, cross-site scripting, cross-site request forgery, and distributed denial of service. For optimal security, WAF, web application firewall, should be combined with secure coding practices, intrusion detection system, IDS, and threat intelligence. Thank you very much, and please let's endeavor to do our assignment.